You want to see something neat? Check this out. The idea is to find the area under this logarithm curve. Okay, so this is the log of x. Hey, that's x. That's y as usual. Okay, and we're going to do a specific area. Well, I mean between a and b. Yeah, so it's a definite integral is how we would do this, wouldn't it? Isn't it? Okay, I mean nothing too new here, except the way I'm writing this. All right, but the trick is you need to do it without using integration by parts. Maybe there's a prohibition or it's illegal or something like that. So how would you get this area? Okay, here's my solution. What is, in your dream of dreams, the easiest integral to calculate? What is it? It's e to the x, right? Easiest derivative, easiest integral, just because it is what it is, right? So let's do that. So there's e to the x. Okay. But remember, this is just the inverse of that log that log function. Except now here we've got a, and here we've got b. So this area above the e to the x curve is what we're looking for, in between b and a. Okay, and that's going to be particularly easy to calculate. First of all, let's work out this area right here. Okay, I'm doing the black pen, red pen, except my eyes are open. I can't do otherwise. All right, so that's just a square. And let's work out what its area is. Or not a square, but a rectangle. So this point here, okay, that's log b comma b. Okay, and this point here, that's log a comma a. Okay, so this is b minus a, this side of the rectangle, and this side here is just log b. Okay, so let's make a note of that. So what do we got? We've got b minus a times log b. So we'll write it like this: b minus a times the log of b. Okay, but of course now we've got this bit to deal with. Okay, we need to subtract that. So what we're going to do, and we're going to do black pen, green pen, red pen. Let's work out this whole green area, okay? And that is our super-duper easy integration. It's the integral, it's the area under the e to the x curve, but it's between, okay, so it's got to be between here. So it's got to be between log of a and log of b. Okay, log of b up here, log of a down here, dx. Okay. And I'll leave it to you to verify this amount, but that just works out to b minus a, which we've seen before, haven't we? Yeah, so this is going to be so cool. Okay, but now problem, yes, big problem. Let's go back to the green, because we took out too much, so we need to add back in this space. And what is that? That is log b minus log a, so that's log of b over a. Okay, that's this right here, and then this, that's just a. So multiply, so this minus this plus this again. Okay, so that is actually that's our between b and a. And this I'm going to simplify because we got b minus a here, and then we're subtracting b minus a. So let's just make that b minus a times log of b. Okay, and that's minus 1, not b minus 1, but log of b minus 1. Add that to a, log of b of a, and that's our solution. And we didn't integrate the logarithm, we integrated e to the x, which is way easier, and we could get away with it because it's the inverse function. Pretty cool, eh?